Well, welcome to part two of week two, where we're looking at samples and populations. And I hope as we're going through this process, you're beginning to see how as we build our statistical knowledge and skills, we're actually able to do work that becomes increasingly exciting. And so means, medians are exciting, scatter plots are exciting, but this week we're going to begin to see how those tools will inform our analysis, and so that we have even more skills and tools in our bag and more opportunity for fun and enjoyment as we look at the data. So as we look at our roadmap, we're going to talk a little bit about the drafting of our question as a way to begin to explore data. So as we begin, we're going to focus on the data exploration and look a bit more in detail about data distributions and how data distributions are related to populations and samples. So we're going to draw the connections between those three concepts. So as we look at distributions, we've talked a bit about them in previous discussions, but now we're going to talk about how powerfully the data distribution can inform and influence the way that we do our analysis to answer our underlying question. So what I'd like you to do is pause for a moment, and I'd like you to describe the distribution of this sample and tell me what your estimate of the mean and the median are for this sample. So pause for a second, look, summarize the distribution, and tell me what you think the mean and median are. So as you probably guessed, looking at these data, the mean observation is somewhere around 180, give or take. We don't have the actual raw numbers to calculate it, but just looking at it, if we take the total score of all of our observations and divide by the number of observations, we're going to be somewhere around 180. You can see that clearly in this histogram. And the median score, so the one below which half of the observations fall and above which half of the observations fall, is going to be somewhere around 180. So as you guess, this is a normal distribution. The mean and median are equivalent or very close, and we have a peak at the center of the data and then a dwindling off as we go out to the sides. So do the same thing for these data. Tell me what distribution you see and where you estimate the mean and median to be, and then come back and join us. So if we look at this curve, this histogram, we see that about half of the values are falling below 185 and about half fall below 185. And our mean score is probably somewhere closer to 195. So the majority of the observations are happening on the left-hand side of this graph, and we have a tail that goes off to the right. So what type of distribution is this? Of course, it's a right-skewed distribution. And in the right-skewed distribution, as we talked about earlier, the mean score is going to be greater than the median score. So if we look at this plot, do the same thing. Guess where your mean and median are and what type of data you think are represented here. So our median is probably somewhere around 207, so that half of our observations are above it, half are below it, and the mean is probably somewhere around 200, looking at this visually. And the tail of these data goes off to the left-hand side. So this is a left-skewed distribution. Now the question becomes, all right, I can recognize the distributions now, what do I do about that? So this slide is a nice printout to summarize how the mean and the median, as well as the mode, are all related to each other in left-skewed, right-skewed, and normally or unskewed data. But I'd like to look at a different type of example where we don't have skew in the same way that we've talked about previously. I'd like you to look at these data and tell me how you would describe them. So as you think about your description, the summary of how these data are distributed is called a bimodal distribution. So we've talked very briefly in our earlier PowerPoint that you looked at on mean, median, and mode, how the mode number is the one that occurs most frequently. And if we looked at these data, we probably would have a mode somewhere around this value of negative 1.15, and we probably have a mode somewhere here around positive 2.3. So bimodal is when you have data that are clustering in two areas, and you can see that very clearly here from this histogram. So if you were to begin to analyze these data, it might be helpful to think about the group that clusters here on the left differently than the group that clusters here on the right. So that brings us to our next section where we talk about analysis. How do we analyze data? The distribution of how the data occur is the key factor that drives our analytic strategy. So what I'd like to talk about is how predictor and outcome variables are related to each other, because that's what we're doing. We're trying to move from describing the data, the mean, the median, the distribution, to understanding relationships between predictors and outcomes. So here you might say, all right, how does predictor X relate to outcome Y? And if we take this example of normally distributed data for a predictor, we say, how are those data related to these other data, outcomes that are normally distributed? So the relationship between those two variables that are normally distributed can be described using a statistic. And that statistic, in this case, the most commonly used one would probably be the t-test. So the t-test we'll talk about more as we go through the course, but is a statistic that compares the mean values of two variables. And so when you have predictors and outcomes that are normally distributed, the mean and the median of those distributions are going to be essentially the same. A t-test is one statistic you could use to compare the means of those two variables. So let's see how that's different in another scenario. So these data, this predictor, has a left skewed distribution. The majority of observations are occurring on the right-hand side of the graph, and you have a tail off to the left. So if we have a left skewed predictor variable and an outcome variable that's normally distributed, how could we understand the relationship between those two? And of course, there's a great statistic that can help us understand that relationship. And in this case, the Wilcoxon rank sum is one choice that we might use among others, but that would be a common one. And that is the rank scored distribution, where we compare not the absolute number here in the predictor, but we compare the rank, how the ranks of these values compare. And so that's a non-parametric statistic. It's one that doesn't depend on a normal distribution. And in the case of Wilcoxon rank sum, it's a test where you use ranks as opposed to numbers. So you see, the statistic that we use to compare predictors and outcomes and relate them together is based on the underlying distribution of the data. If I picked a t-test to understand this predictor that has a left skew, then I get a statistical answer when I run that analysis, but it's not interpretable, or it's not the optimal test. So our goal in looking at descriptive statistics is understanding the mean, the median, the measures of central tendency, and the variance of our data so that we can pick the best statistic for our purpose. So let's advance our discussion now and look at these bimodal distributions. So in this group where we have clusters of observations on the left-hand side of the graph and on the right, the question becomes, well, how will we relate this predictor to our outcome variable? And the statistic that we could use in this case might be better to be stratified. We might want to group the observations here on the left into one category and those on the right into another category before we run our statistic. And if we made those two groups, you can see the data observations in this group are close to normally distributed, but we don't have a full right tail on the cluster on the left-hand side, because the cluster of the right-hand side those observations begin to escalate, where we would normally anticipate a tail in normally distributed data. So we can stratify into two groups, but then this group is going to have the majority of observations on the right with a left tail. So those data would then be left skewed, and the group here would have the majority of observations on the right-hand side with another tail out to the left. So again, a left skewed distribution. So if we wanted to compare group A and group B for our outcome variable, we may very well group them into A and B groups and then use a non-parametric statistic like Wilcoxon rank sum, because this predictor variable overall is bimodal, but when we group it into our two categories, is actually skewed. So hopefully we're seeing how the underlying distribution of the data guides our choice of an analytic statistic. And so selecting the statistic really is based on first understanding the distribution of the data. And that is accomplished very well using a histogram. So pause for a second. Think if you have any questions, things that come up, issues. Review some of these key graphics and see how the distribution of the data and the analytic statistic are related to each other. And we'll join you back for part 3.